3, 2, 1. Oh! Hello and welcome to our presentation about mangroves featuring Ada, Lainey,
Dominic, Casey,
Nathan.
Alrighty, thank you so much. Now get out of the way. Alrighty, so when we get going, oh, click the button. There we go. So our presentation is focusing on this paper, Contributions of Mangrove Conservation and Restoration to Climate Change Mitigation in Indonesia. This was received July 18th, 2021, and accepted March 10th, 2022. So it's a very recent paper. Alrighty, so for background information, there we go. Mangrove forests are important carbon sinks. So a mangrove forest, if you don't know what that is, it's a type of tree. They have these really big root systems that are above the water. I forget what that's called. Taproot? Prop root. One of those. Sorry, Rebecca. And they can intake 4 times more carbon than rainforests. So they're really important carbon sinks. They take in this carbon and they're able to use it up, so there's not as much carbon in the air. And also much of the carbon is stored in the soil that they live in. Okay. So obviously, like I said, their roots are out of the water a lot of the time, so they are able to hold a lot of the sediment in. So this provides a nursery system to fish and other wildlife and such like that. So you can see from that little picture, there's a bunch of little fishies in there. I hope you can see. Also, the main issue here is that they've been subject to deforestation. So this is mainly due to coastal expansion. So as places like Indonesia are getting larger, they're kind of expanding out to the areas where the mangrove forests are, so that expansion can happen. So Indonesia has the 4th highest population in the world currently, and it is growing, but it has the 15th largest land area, so in proportion to its size, it doesn't really have a lot of space for people to expand. So this is just a picture of deforestation in these mangrove areas. You can see they've just been completely clear cut, and so this should be filled with water. It is not, so they pump out the water and clear cut all of these forests as well.
Right. So moving on to the methods of this study, they used 7 different sites, which I am going to say them and I'm probably going to butcher them. So they were Java, Kalimantan, Bali Nusa, Tenggara Islands, the Molucca Islands, Papua, Sulawesi, and Sumatra. And up here is a map of Indonesia, so all in that area is where these forests were. And in order to decide what kind of mangroves they were going to be assessing, the requirement was that carbon stalks were 3 meters when the soil was greater than 3 meters deep, and 54 total mangroves qualified for the study of this project. The researchers studied a bunch of different parts about mangroves in order to assess if they were doing well or not, and one of those were the emission factors. So the total emissions were due to land cover change and shifts in the NEP due to land conversions. And emission factors were calculated based on if the mangrove was changed to something other than restored mangrove. And the other option that they used was a shrimp pond. So basically what it was, yeah, you can go ahead. Yeah. So this is a picture of like what a shrimp pond looks like. So some of these mangroves were being torn down for deforestation purposes to, make paper, that kind of thing. And so they either were restored into a primary, like remade mangrove, a secondary mangrove where they didn't chop down everything and just like let plants keep growing, or they changed it into a shrimp pond, which is bad, terrible, no trees, a lot of shrimp, ew. So the primary conversion to secondary conversion, there was no changes, is what they found. And then secondary forest to a shrimp pond, there was a 29% difference of carbon stalks. So carbon being released into the environment was a lot higher whenever the forest was cut down and turned into a shrimp pond. The land cover data, like where they got all of this data from, was from the Indonesian National Forest Monitoring System, which is just like an online software system. So they didn't actually go out and like find all these mangroves and that kind of thing. The information was already like discovered, recorded, that kind of thing. And researchers broke each of these mangroves into 4 different categories, which were used for deforestation, reforestation, like I was talking about, the primary, secondary forest, growth, reforestation, I just said that, yeah. And then net deforestation was calculated by adding all changes in each environment, like the good ones and the bad ones. You can go ahead. So this is just some pictures of the little reforestation. You can see the little itty bitty plants were being planted and they're pulling out the bad things like cattails and that kind of thing. So CO2 emissions were calculated by the total emissions and the loss of mangrove per year. And mangrove pathways reduce greenhouse gas emissions, which makes sense if you think about how the Earth is similar to a greenhouse and we have all of these emissions going up into the air. Like Ada said, mangroves are carbon holders, so they hold in the carbon, but if we're cutting them down and making shrimp ponds, then obviously you're gonna have a higher CO2 emission into the environment. So another proposed thing that they said they should do is the avoided mangrove deforestation and degradation pathway, basically just outlawing all deforestation of mangroves to keep these CO2 emissions down. Or the mangrove restoration pathway, which is taking areas like the picture that Ada showed where everything's dried out and restoring that to what it was, planting those species and getting the mangrove back up and running. And then they also, of course, had to calculate the uncertainty for maximum mitigation potential, which was just a lot of mathematical models to see if this was a good idea or not.
So while reading this paper, we as a group struck up some questions that really weren't answered in the paper. The first one was based on the information provided within the research paper. There are many different aspects of mangrove restoration and preservation to be explored. With all these efforts being taken to restore and preserve the mangroves, there's limiting knowledge within the paper regarding what efforts are being taken and how effective the restoration and preservation strategies are. And that strikes the question, like, what efforts are being taken? Alongside the actions to preserve and restore the mangroves taken by the government in Indonesia and other organizations is the efforts and awareness of the indigenous people and community that live in the area of the mangroves. And that strikes the question, what actions are the indigenous people and local cultures taking to help? And then the final thing was, what are the best restoration and preservation tactics that are proven to be effective? And us as a group, like, looking more into the preservation and restoration tactics that are proven to work would enable a greater understanding of the mangrove's importance and value to the world.
So, the results that we concluded, or the results that we got from our research paper were as follows. The graph here displays the results after the full 10-year study and shows where the deforestation of mangroves has occurred and why. So agriculture made up a large portion of this and resulted in a 19% loss of these trees. Along with that is aquaculture, which is, like we talked about before, is like shrimp ponds and such, or even like seagrasses and kelp farming. And that made up for 46% of the deforestation. And the remaining 3% was infrastructure built by individuals, private companies, and the government, just generally. Beyond that, the remaining 32% was just forest degradation, which is also what they found. Like, in many of these old mangrove, like, forest areas, there's not a lot of new plants. It's a lot of older, like, dying and decaying plants. And so on top of the deforestation caused by people, just old forests are starting to overtake new forests, and there's not new growth. So in total, 128,176 hectares a hectare being 10,000 square meters, were discovered to be deforested during this 10-year project.
So what did this study conclude? So first off, they found that mangroves are valuable components of national climate solutions that assist in achieving national determined contributions. So essentially they found that mangroves were excellent at carbon storage and providing other environmental related positive outcomes, so to speak. And so from there, they determined that it was actually beneficial towards climate solutions and contribute to reduction in greenhouse gas emissions. So the second thing they found was there some limitations still exist on current climate change mitigation strategies for Indonesian mangroves. So essentially the focus is primarily on large-scale mangroves currently, which is great and all, but unfortunately, however, at the rapid loss rate that mangroves are decreasing at, they determined that they don't know if it's suitable enough to keep up with the rapid decline. The third thing they found was mangrove conservation is more effective at reducing harmful emissions than restoration. They found a noticeable difference between taking a conservation approach to it rather than planting new species and going with the whole restored route. And then finally, the study concluded that there needs to be more advocacy for an inclusive approach that kind of incorporates both conservation and restoration together, that ultimately will then increase the mangrove populations throughout Indonesia. And last but not least, if you could take away one thing from our study today, it's that stop the shrimp ponds, please. All right, we want to keep our mangroves in Indonesia and across the world. Very beneficial to carbon and reduction in greenhouse gases, so please, stop the shrimp ponds.
Thank you so much.